By now you should be a master of moles. You should be able to go grams to moles, moles to grams, grams to moles to molecules, grams to moles to molecules to atoms, atoms to molecules to moles to grams, everything in between. You should be able to do all of the conversions to go with moles, but like, why? What's the point in doing all of this? Well, the reason that we do molar conversions is to relate substances, because remember, substances have different masses. And in chemistry, we're actually trying to do chemistry to make things, to create compounds, to control environments, to develop substances. And that means we actually need to know how much stuff we want to make. And in order to know how much stuff we want to make, we employ what is often called stoichiometry. And if you've ever learned about stoichiometry, you may have seen it and thought how confusing it was, but I want you to understand that it's actually something you do all the time. It's actually quite easy. And it's just a matter of practice and habit and learning how to do it. But what is stoichiometry anyway? So, stoichiometry actually just comes from two different terms. It comes from stoichio and metry. Metry means to measure. And stoichio is about amounts. So when we talk about stoichiometry, what we're actually talking about is the measurement and relationship of the amounts of substances. And so stoichiometry may seem intimidating when you first start it, but it's actually something you do all of the time. And you don't even think about it. It's just that when you start working in chemistry and we start using different units and different words and compounds and formulas and all these things, it can sometimes seem a little overwhelming. But I'm going to show you an example of stoichiometry to show you that it's something that we literally do without even thinking about. You see, stoichiometry is about the relationship and amounts of materials and things. And so this is a classic example of a stoichiometry problem. How many bologna sandwiches could you make with 32 slices of bread? Chances are you may already know the answer in your head, and that's because, like I said, you do stoichiometry all the time. Stoichiometry is just about understanding ratios and relationships between things. But let's actually show how we would do the math to get this answer. So, how many bologna sandwiches could you make with 32 slices of bread? So here's what we're going to do is the same thing we've been doing all along. We're going to start with what we know. I know that I have 32 slices of bread. And let's think for a minute. What is my actual relationship here? Well, the relationship is like a formula or a balanced equation. In order to make a sandwich, we need bread. But this is a bologna sandwich, so we also need bologna. And combining these, we will end up getting our sandwich. Now, a sandwich is made of 2 slices of bread, and we're not millionaires here, so it's only got 1 slice of bologna. So then we need to balance our equation. And you can see that for every 2 slices of bread, we're going to make 1 sandwich. Now, hopefully you already knew that, but I can use that relationship to create a ratio to say that for every 2 slices of bread, I will make 1 sandwich. maybe we should label this. Now, 32 divided by 2, breads cancel, and I get 16 BD2BLs, or 16 sandwiches. So do you see what I mean? Stoichiometry is really just using the relationships between things, using the amounts of things that we already know, and using that to help us figure out how much we can actually produce by the time that we've finished. So this is all well and good. We've done this example, but let's do an example that actually relates to chemistry. And so we're going to do a calculation, and I'm going to show you my 4 steps of stoichiometry. And if you follow these 4 steps of stoichiometry, it will work for every single stoichiometry problem that you ever do, especially in a chemistry class. And so let's take a look at how we can do this. So here's the example that we're going to do. What mass of oxygen gas will react with 15.0 grams of hydrogen gas when making water? So I mentioned that I have 4 steps that we need to follow in order to do stoichiometry. So step 1, we need a balanced equation. In order to do stoichiometry well, we need to write a balanced equation to learn the relationships between those amounts of things. So let's start with that. We need to read through this question and figure out what's going on. What mass of oxygen gas will react with hydrogen gas? So hydrogen is H2, and it's a gas. It's reacting with oxygen, which is O2, and it's a gas. Remember, hydrogen and oxygen are some of the diatomic elements, meaning that they always exist as 2 atoms connected in a molecule. They're going to react to produce water. Now, it doesn't tell us what state water's in, but let's make it a liquid for this reaction. So I now have my equation. 2 hydrogens react with 2 oxygens to make water. Hydrogen reacts with oxygen to make water, but this is not balanced. So we need to balance this equation before we can go any further. I have 2 oxygens here and only 1 oxygen here, so let's put 2 oxygens here. That gives me 4 hydrogens, so I need 4 hydrogens. And now I have 4 H's, 4 H's, 2 O's, 2 O's. So I now have a balanced equation. Step 1 is done, but what I also like to do is give myself a little bit of extra information here. I like to sort out what I know in my equation, and I know that I have 15.0 grams of hydrogen gas, and I also am trying to find how much oxygen gas is going to react. So that is step number 1. Write a balanced equation. So let's go on to step number 2. Go to moles. So what that means is find the information you were given at the start and change that information into moles. And so what I need to do is take the number that I know, 15.0 grams of H2. And the only way that I can actually relate substances is using their coefficients. And those coefficients, remember, represent the number of atoms, or in other words, the number of moles. So I have to change grams into moles because grams don't do me any good when relating substances together. And so we're going to change 15.0 grams of H2 into moles of H2. So that means grams of H2 is going to go on the bottom, moles of H2 is going to go on the top, and there is 1 mole for every 2.02 grams of H2. So what's that going to do? Well, that's going to cancel out grams and convert into moles. So step number 2, go to moles, done. So step number 3, molar ratio. This is the new step for stoichiometry. This is actually nothing new, right? We've written balanced equations before. We've done molar conversions from grams to moles before. But now what we need to do is convert moles of hydrogen to moles of oxygen. And remember, to do a conversion, we need a ratio. And luckily, we have one. The ratio is going to be the moles of hydrogen to the moles of oxygen. And you notice the coefficients are the moles. We want to get rid of hydrogen, so that means moles of hydrogen is going to go on the bottom to cancel out, with moles of hydrogen on the top over here. And moles of oxygen is what we want to find, so it's going to go on the top. There are 1 mole of oxygen for every 2 moles of hydrogen. So that's going to cancel out moles of hydrogen and leave me with moles of oxygen. Keep in mind, I'm just doing these different steps, really all in one large conversion. But this was step number 1 right here. We had our balanced equation. This was step number 2. This was go to moles. This was step number 3. This was the molar ratio. The only really new step that we're going to encounter in this whole thing. And I said there's 4 steps. So what's our last step now that we've done our molar ratio? Go where the question asks. We really just need to think about what is this question trying to get us to do, and how do we get there? Well, the question is trying to get me to find out oxygen gas, but it's saying mass. So how many grams of oxygen can I actually make? So we need another conversion. And I need to take this number of moles of oxygen and convert it into grams of oxygen. Now, luckily, I know a conversion for grams of oxygen to moles of oxygen. This is going to be the molar mass. 1 mole of O2 has a mass of 32.00 grams. That was my final step in stoichiometry. This is step number 4. Go where the question asks. So now all you need to do is punch this through on your calculator. So 15.0 divided by 2.02 divided by 2 multiplied by 32, my answer comes out to be 118. We're going to round that up to 119. So what does this really mean? Well, what this means is if I started with 15.0 grams of hydrogen, and there's like, let's pretend an unlimited amount of oxygen around, which is a pretty good bet because there's a lot of oxygen around. It would be able to produce, or it would actually need to react with 119 grams of oxygen in order for this whole reaction to work out so that all of the hydrogen was used up. So you see, stoichiometry may sound complicated. It may look complicated, but once you learn it, it's just a balanced equation. Go to moles, molar ratio, go where the question asks. And as long as you understand how to do those conversions and how to set them up, it's actually something that is very manageable. But as with all things in chemistry, go practice. Make sure you ask any questions if you're having trouble. Good luck with this, and I'll see you next time.